All right, let's take a look at the Chapter 7 test review. This is over conic sections. So there will be, I'm just going to kind of give you in advance, there will be problems that you will notice on the test where you use the same equation multiple times, all right? And so your online tests randomize the questions, so they might not be back to back, but for the test review, we're going to do a couple questions off of one equation. So in particular, I shouldn't say a couple, we'll do 3 questions off of this one equation. Our calculators can handle this equation just fine in this form. However, this is not the form I would recommend leaving it in. When we look at the formula chart, anytime you have let me open up the formula chart here. Anytime you have 2 quantities squared, you're either dealing with a circle, an ellipse, or a hyperbola. If you have 2 squares, it's not a parabola. A parabola only has 1 term squared. For that reason, if you notice what's common between an ellipse and a hyperbola is they're both equations are set is equal to 1 for both ellipse and for hyperbolas. The circle, it's going to be equal to the radius squared, but it has no coefficients. This is not a circle because this 81 right there. That 81 determines it's not a circle. And so what I would recommend doing first is dividing this by 81. And if you divide one thing by 81, you have to divide everything. Because multiplication and division are opposites to one another, we don't talk about this often. You have to distribute division as well. You know, we know that with multiplication you're supposed to distribute, but with division you also need to distribute. So the actual equation we're going to be looking at would be y minus 8 quantity squared over 81 plus these 81s could just cancel out. You could just write this as x plus 4 quantity squared equals 1. All right, so what shape is this if the 2 quantities being squared are adding together to equal 1? Would it be an ellipse or would it be a hyperbola? It's an ellipse. Specifically, it's this vertical one because the number underneath the y squared is 81, which is longer than basically 1 for b squared. So it's going to be a vertical ellipse. Now here's what I'd recommend second. When you're on the test, I'd have this open if I were you, the Desmos pre-programmed calculators. And once you determine what the shape is, go click on it very specifically, the correct one. So this is an ellipse, we said. So I'm going to click on this ellipse. We haven't done as much of this in class. We've really focused on a lot of algebra. Now I'm going to show you how we can use this to help us out. The thing you need to be careful of are the values I'm asking you to plug in are not the squared values and not the lie values. I'm asking you to plug in the exact values as shown. So the y needs to have a minus 8. That means k is 8. Because remember, inside lies, so it's just that value 8. The h value here is a positive 4. That means I need to enter it in as a negative 4. Underneath the x squared, it's like being divided by 1. And so that would mean the value underneath the x is 1. On my calculator, that value is always a. So a is going to be 1 here. And the value that's underneath y is 81, so it would be this square root of 81. You could, if you wanted to, that's at the b, you could just type in, if you don't know that the answer is 9, you could put a 9 if you do. But if you don't, you could just type in square root 81 like that, and it'll solve it for you. That's because this is b squared. For my formula, I have it written, it's b squared. Okay, so there's your equation. And all the values are solved in here. So as I try to solve this, let me shrink this a little bit. It says find the coordinates of the center. If you didn't know the inside lies, it's going to be negative 4, 8. I guess that one we could have solved very easily without even using the calculator. Negative 4, 8, just by saying inside lies, negative 4, positive 8. Find the coordinates of the foci. So Desmos gives me these values. The foci is here in purple. If you click it, let me zoom in on it, hit like this. If you click it, it tells you it's a foci. Here are the 2 coordinates there in purple. So let me zoom out so we can see them both. It's negative 4. Negative 4, both of them are negative 4 on the x. The y value is 16.944. And the other one is negative 0.944. Now on the test, they're going to use exact numbers, which means they're going to have square roots and stuff like that. These are rounded decimals. These are the two foci from the calculator. But the formula chart actually can help us with this. On ellipse, we know it's vertical. It says the foci is going to be h, comma, k plus or minus c. H, comma, k plus or minus the c value. And so if you just plug these in off of the equation, you could write down these values. Did I never even put what c is? Ooh, I need to add that. I'm going to add what c is when you click on foci here. Let me put, no, I never clarified what c is. Sorry, hang on one second. I'm going to update this for us in a second. So it'd be plus or minus this number, which is the square root of, let's see what that is. Square root of 80. That's right, the square root of 80. So what our actual, the way it would show up on the test is the value be written as -4, comma, the center is 8. So it'd say 8 plus and minus the square root of 80. Don't worry, I will have this added in on the foci so you know what the values are in the future. I'm going to go ahead and save this now so I don't forget. But that's how it would look on the test is right here. But what I was going to show you though is, so let's say that's the test and Desmos is showing you these two values. If you type in just any one of the 4 answer choices, only one of them should give you those numbers. So if I type this in, like let's say you're on that one, that's your answer choice A. If you type that in, say, okay, what is 8 plus square root 80? You'll get that same number that we had right there, if that makes sense. Okay. So square root of 80 we could reduce. I'm aware of that. So technically on the test, it wouldn't show up as square root of 80. It would show up as, let's see, I'm going to use upside down division. I'm going to use prime numbers. 2 goes into 80 40 times. 2 can divide into 40 20 times. 2 can divide it into 20 10 times. And 2 can divide it into 10 5 times. That's all prime. You circle up pairs. So there's pair of 2s, another pair of 2s. That means this is 2 times the square root of 5. Or said another way, it would actually look like this: -4, comma, 8 plus or minus 4 square roots of 5. That's actually how it would look on the test. All right, vertices and co-vertices. So I'm going to come back over here. I'm going to open up vertices and co-vertices. Then, well, you can look on these points to see them easier. It looks like -4, comma, 17. The vertices, I'll do the vertices first. Remember, those are the major ones, the 2A, -4, comma, 17. And the other one is -4, comma, -1. By the way, that's because A is 9. If you look up here, or excuse me, K, no, where is it? B is 9. According to the formula, you go up and down 9. You go up and down 9 from the center. That's how you get those values. 8 plus 9 is 17. 8 minus 9 is -1. That's how I got those. And then co-vertices. Again, you can go off the graph for these. I'm just trying to connect the algebra. Co-vertices would be the two side ones, -5, comma, 8 and -3, comma, 8. That's because it's from the center and it's 1 unit either way, because the denominator is 1. Square root of 1 is 1, so it's 1 unit either way to the left and right. All right, so that's how you can use a calculator to help you out on that if you don't remember your algebra. The algebra that's involved in this is, and I'm just going to move on after this, is that the center is your h, comma, k. That is h comma k. I gave you the formula for these two. This is your formula here. I'll star up the formulas here. That's the formula for vertices. The formula is h comma k. This would be technically an a plus and minus a, if that is your a squared right here. If that is a squared, then it's h comma k plus or minus a, and then this one is h plus and minus b comma k. Those are your formulas. If you label it properly, with a squared being the larger number, b squared being the smaller number. Okay, so if you're doing algebra, that part in black is how you would get those answers. Again, we're taking online tests, so if you have those formulas down, I'm not going to count off for it. That's just you being smart. All right, number 4. It says use the discriminant. Now, you might not remember this term because I went through it really fast because I said, you know, today's technology, we're not going to use the discriminant. If you have to identify the conic section, just graph it. So I want to get a blank graph. The easiest way here, I can either close this tab, and then on the Desmos graphs, I'll go up to the top where it says blank. And I'm just going to type in this equation right there. 15y squared plus 15x squared plus 7y plus 23x equals 13. What shape? It's a circle. Answer is a circle. If we would have, if you wanted to use algebra, you'd complete the square there. So anytime you have two squareds like we do here, you would keep your constant alone. That would be the pre-step. Get that by itself, which it is. You would pair up the y's and the x's and leave gaps and complete the square. And that's how you come up.
Can you give a brief summary what a discriminant is?
Discriminant is where they use the formula b squared minus 4ac. Determine the shape based off of the math, and I don't have it in front of me. I believe it's if it's negative, it's an ellipse or a circle. If it's equal to 0, it's a parabola. And if it's greater than 0, it's a hyperbola, I believe, where you plug in these numbers. When you use the discriminant, a is reserved to be the number of x squareds, b is the xy term, and c is the y squareds. So that's in brevity what you would do. So in this one, I have 0 xy's, so it'd be 0 squared minus 4 times my a is 15, my c is 15. So I'm getting, I think that's negative 60 times 15 is 900, I think. You can check the math, but we know it's negative, right? If it's negative, if your b squared is negative, less than 0, that means it's an ellipse or a circle. Okay, if it's an ellipse or a circle, meaning if it's negative, it's a circle only and if and only b equals 0 and a and c are equal to one another, which this is the case. B is 0 and a and c do equal one another, so it's a circle. But any other scenario, if b is not 0 or if a and c don't equal one another, it's no longer a circle. I'll just show you by experimentation. I'm going to change and make x and or the a term and the c term not equal to one another. I'll change it to a 14. Well, it's hard to tell because it's so close, but you can see as I get smaller and smaller here, you see how it's becoming more and more elliptical. So the more different they are, more elliptical. If it was a negative, now, because of the negative, this would be positive. And if it's positive, it's a hyperbola. So that's what happened there. And did I forget a parabola? To get a parabola, you would need it to equal 0. So let me just make it be 0x squareds. It's now a parabola. Zoom out, you can see it's still a parabola. So that's what the discriminant is. I think it's easier just to graph it and not have all those memorizing little rules. Just graph it and see. Or complete the square. I honestly think completing the square is quicker than trying to memorize all those rules. Number 5, it says write a pair of parametric equations for x equals 12 cosine theta and y equals 9 sine theta in rectangular form. Remember, that means in terms of x and y. There were 3 steps for this. Do y'all remember what the 3 steps were? Typically, if there's a t involved, we say solve for the shared variable. But if there's trig, it was solve for the trigonometric function. And I should say that plural, trigonometric functions. So that's what we're going to do first here. Is if you have x equals 12 cosine theta and y equals 9 sine theta. I just realized I might need more space. Let me slide this over a little bit. Whoops, that's not what I want to do. Let me slide these over. Okay, how would I solve for the trigonometric functions? Well, this 12 is multiplying. What's the opposite of multiplication? Division. And over here, that was kind of an ugly deal right there. Let me clean that up a little bit. There we go. And so we find out that cosine is equal to x over 12. Sine is equal to 9 over 12. Step 2, when you're dealing with trigonometric functions, is you substitute into the Pythagorean identity. Okay, so if I pull up my formula chart, my Pythagorean identity, and I'm going to use the one that has sine and cosine. There it is, Pythagorean identities. It's sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. And so cosine we know is x over 12. So if 1 cosine is x over 12, that means cosine squared would be x over 12 squared. Same concept applies for sine. If sine is y over 9, then sine squared is going to be y over 9 squared. And all this equals 1. What I observe when I do this is we are going to have an ellipse, 2 terms squared. They're adding different denominators. It's going to be an ellipse. Step 3 is to simplify. And so let's see what this ellipse looks like when I simplify it. I'm going to write the x term first because it's larger. I would have x squared over 144, that's 12 squared, plus y squared over 81 equals 1. This would be a horizontal ellipse that would go left and right 12 units, up and down 9 units, centered at the origin. So what could you do if you don't know that math? Is you could open up the Desmos graph called Parametric, where is it? Parametric Equations, graph number 22 here. Parametric Equations, when I open this up, I could graph the original 2 equations they gave me, that x equals 12 cosine theta. For my calculator, do not use a theta. You need to use a t, 12 cosine t. Y equal 9 sine t. There's our parabola. You're not seeing the whole parabola because there's not enough time involved. So typically with thetas, we talk about from 0 to 2 pi. So I'll just change this from 0 to 2 pi. That's 1 full revolution. And now you should see the full circle. If you remember that this is now review, just connecting some trigonometry. To go all the way around a unit circle, it takes 2 pi radians. Well, it's the same thing with an ellipse. To go all the way around, it takes 2 pi. So if I did 1 pi, you'll get half the ellipse. Semicircle. If I did 3/4, not 3/4, I'm sorry, 3 halves. That's 1.5 pi. You get 3/4 around. Now you know why I said 3/4. If you want 3/4 of the way around, you need 3 halves of the pi. Not 2 pi, not 1 pi, but 1.5 pi. But 2 pi would get you all the way around. Okay, so that's how those work. One thing about this, it's very particular to know, if you put your cosine on the y, remember sine is y, cosine's x. If you flip those, what happens is it switches, I'll show you this. It switches where you start and the direction in which you rotate. Now we're going to start up at the top and rotate this way. And so if I only went 1 pi, you'll see it's a semicircle. It starts here and goes this way, as opposed to starting the positive x-axis and going counterclockwise. You start in the y-axis and you go clockwise because you took the inverse. Is really what you did. You swapped your domain and range values, your sine and cosine. And so instead of starting the x-axis, you start in the y. Instead of moving counterclockwise, you move clockwise. So that's how that works. All right, number 6. It says Randall hit a golf ball with a velocity of 100 feet per second at an angle of 29 degrees with the ground. Find the distance the ball travels when it hits the ground. I have a calculator also for this. On this one, I will show you the algebra. But I want you to know, if you're going to use the calculator, which is definitely the easiest to do, there are 4 pieces of information we have to find. 3 should be given to you in your problem. They should give you initial velocity. They should give you a theta. They should give you an initial height. Those 3 are essential for you to solve. One of the things that is also essential for your calculator to get the calculations right is the gravity coefficient, depending on what your unit is, feet or meters. Change colors. Now, for my calculator, depending on the problem, you might have an x value also given to you or a y value given to you, and my calculator can handle those. I'll put those on the sides. These are optional. If you're using the calculator, these values would be optional, but these are required to solve this correctly. Okay, so let's fill in the information. What do you see that about for the initial velocity? It's 150, and our unit is feet per second. So we're in feet, which means for gravity, there's 2 options. It's 32 if it's feet, and it would be 9.8 if it was in meters. 32 feet per second squared or 9.8 meters squared. This is feet, so it's going to be a 32. All right, what about a theta?
29 degrees.
29 degrees. Okay, now the initial height can sometimes be tricky, but the ground is telling you, that word ground is telling you a height. What's the height of the ground?
0.
0. We want to know the distance the ball travels when it hits the ground. They did not give us an x and y. This would be the optional for the end result. Optional, let me write that in there, for end result. But they didn't give us anything. So I'm going to leave that blank. If you want to use my calculator, it's calculator. It's right below the parametric equations. 23. I shouldn't read the numbers because I'm recording this in the future. It might not be 23. I might have other calculators. But for now, it is projectile motion number 23. I'm going to open that up. And so we'll type in these values. That's going to be for the time, so you can see the ball as it travels through. But we said it was 150 feet per second feet per second. The angle was 29 degrees. The initial height was 0. All right, we want to know how far does it travel when it hits the ground. It looks like the answer is going to be just short of 600. Okay, I just want to make sure you're interpreting that. If you go to the end result, the first 2 items when you open that box up are the x horizontal and the y vertical. Those are these optional pieces. Like if they said the hole is 550 feet away. Does he hit the golf ball to the hole, past the hole, in front of the hole? If it was asking one of those questions, that's where you'd fill in a value here. So like you say, okay, the hole is 500 feet away. Does he hit it? And that's how you could interpret, oh, he would hit the ball past 500 feet. But they didn't give us either one of those, so I'm going to ignore that. What we want to know is how far does it travel when it hits the ground? That is one of the things I've had programmed to always solve. It can solve when it travels this x distance, the projectile when it reaches this height. I program those 2 things first. But there's 2 other items that I always have solved. I always solve for the maximum height, and I also solve when it hits the ground. Those are programmed to always give you the answers. We're looking for when it hits the ground. This is how much time it takes, 4.5 seconds. And this is the distance, 496.3 feet. I'm going to round, and I will say that is approximately 596.3 feet is the distance that golf ball travels. Okay, you want to do a little algebra. What could we do for algebra is, oh, by the way, I guess the one thing we didn't have for this, I just thought of it now, is we want to know when it hits the ground, which means the height is 0. So I guess we could have just put a 0 here. And if you put a 0 there, I know it makes this dot go down to 0. Now, if you look at the second section projectile, when it reaches the y height, so we just programmed to be 0, you'll notice it's the same answer. So now we're getting the same answer in 2 sections, the y height section and when it hits the ground section, same exact value. Okay, let's say you want to do algebra. How would you do it? There are formulas on the formula chart for projectile motion, the vertical position, the horizontal. What I'm going to do is I'm going to copy these down. So here's your formula. So this is just a rundown of the algebra. Those are our 2 formulas. And you would plug in the information you know and solve. We want to know how far, what distance, find the distance. So that means we were solving for x. That's what we were looking for, the x value. So that would be, for algebra, the last thing that you would find is right here. That's what we'd be solving for. So I would end up having to start with this equation, solve for what's missing, which is going to be time, and then plug it in. So I'll walk you through it really quickly. If it's too fast, I'm sorry, but I'm just going to go through quickly. The y is 0. So 0 equals t times 150 times sine of 29 degrees minus 1/2. Gravity is 32 feet per second squared plus an initial height of 0. If I'm doing the algebra, anytime you have a power of unknown, your unknown has a power of 2 or greater, you need to factor to solve this problem. The 0 goes away. I don't have to do X method because the C disappears at 0. So all I'm left with is AX squared and a BX, if you think in terms of quadratic, which means I can do a GCF here. They both share a T. If I factored out T, I have T times 150 sine 29 degrees minus 1, I'm going to simplify that. 1/2 of 32 is 16 minus 16t. Since they're both equal to 0, we know this 0 product property says that if you multiply with the product of 0, one of these two equals 0. So at times 0 is a possibility, but times 0 means we haven't hit the ball yet. So that's not our answer. Or it's going to be when 0 equals 150 sine 29 degrees minus 16t. So I will solve this part now. I'll add 16t, and to get our solution, I need to divide by 16. And so when I divide this by 16, we're going to get that 4.5 seconds value we saw in my calculator earlier. That value right there is going to be 4.5. Go to calculator. It's going to be this number right there. I'll prove it to you. 150 sine of 29 degrees divided by 16. You see how they perfect match up? Now that I know what t is approximately 4.545 seconds. You would take the t and you'd plug it in right up here. So I'll just go right here with this. I will say the x value is going to equal that time, 4.545 times the initial velocity of 150 times the cosine of 29 degrees. So let's type that in. And we should get that 596 when we type this in. 4.545 times 150 times the cosine of 29 degrees, 596.27. So that's how you do the algebra. Calculator's a lot quicker though. A whole lot quicker. All right. Let's try number 7. It says a cross-section of a satellite dish is shown in the shape of a parabola. How far should the antenna be placed from the vertex? This question is basically saying, where should we place the focus? Because the antenna on a parabola is the reflection point. It's where you get the signal. So we want to know, where should this focus be placed? That's what I'm trying to find. All right, so how would you do this? Well, the first thing I would suggest is to take the parabola equation. So the parabola equation, let me extend this back now. Depends on the shape of it, but we have a parenthesis squared equals 4p times another parenthesis. Parenthesis squared equals 4p times another parenthesis. The p is the focus, that focus distance. As I see on my picture, that focus needs to be placed somewhere on the left and right. I don't know where, but it's going to be somewhere along this center line. You see how it's moving left and right? If it's moving left and right, that means that p-value for the focus needs to be placed next to x. So this would be the equation we're using. The brilliance of doing a real-world problem is that you get to pick where you want your vertex to be. There's no grid here. There's no like x and y graph. So you just get to pick a point to be the center or to reference everything else off of. I'm going to choose this vertex, the HK point here. I'm going to choose this to be the reference point 0, 0. Now you might ask, why do I choose 0, 0? Well, because if I choose 0, 0, I can just say this part of the formula goes away. It simplifies the problem. So I'm dealing with y squared equals 4px. Now you might be thinking, okay, so how do I solve? Well, we are so used to all of our lives, we're graphing on the x and y axis because you have two unknowns. And with two unknowns, you can't come up with a solution, but you can come up with a relationship where you graph it based off the independent x and the dependent y. Well, the same is true here, but you got to think about that parabola represents those two unknowns. Whatever x is, y could be two different, y could be values all the way along. So here's what I can do. If I just find a point that happens to be on that parabola, just any point, if I can find any other point, if I take its x and y value, I can plug it in to solve for what the p has to be. So on mine, I don't know this point, but I could find this point right there. This point is 2 units right. It's 2 units right of the vertex, and it says it's 4 units up. That is an x and y value. So I could solve this problem. Again, this x and y represents any x and y that's on the parabola itself. If I plugged in the 2 and the 4, I could solve this problem. We would have 4 squared equals 4p times 2. You could use parentheses, but you don't need them since there's no negatives. So anybody know what 4 squared is? So 16 would equal, and 4 times 2? 8p. We divide by 8. Our answer is 2, and our unit is centimeters. The antenna should be placed 2 centimeters away from the vertex. So if I was going to draw mine perfectly, I would need to move that focus to right there. That's where we should place the focus. All right. For 8 and 9, use this hyperbola. It tells us it's a hyperbola. This isn't a normal hyperbola form. To get a normal hyperbola form, we need to set it equal to 1. So I'm going to divide by 36. I showed you the algebra earlier, so this time I'm going to just kind of go faster and just go grab the digital answer here. Well, we'll see. Maybe I won't. Again, this could, you could say it's over 1. You could leave it like that, or you could say over 1, whichever you prefer. All right, so it says write the equations of the asymptote. Actually, I'll do algebra and I'll do graphing. So let me come over here. I'm going to close these off and open up hyperbola. This is a vertical hyperbola because the y squared comes first. So when I go to hyperbola, I'm going to select vertical as it shows here. The y squared is the positive fraction. The x squared is the negative fraction. And so it's y plus 5. That means my k is a negative 5 because inside lies. Use a lie. X has a 0 with it, so h needs to be a 0. The a value is the square root of 36, which it is going to be 6. But if you didn't know that, you can do square root 36 and you get 6. The b value would be the square root of 1, which again is 1. So that's what our shape looks like. It says grab the asymptotes. If you go to asymptotes, this tells us our 2 equations. So we can plug this in. The y minus k is there. The x minus h is there. So the equation would be y plus 5. That's the y minus k. That's what it's saying right there. Equals a divided by b. If you're like, what is a, what is b? Well, they're right there. 6 divided by 1. And there's a positive one and a negative. So it'd be just plus and minus. 6 divided by 1 is 6 times x minus h, which happens to only be x. That's the equations of your asymptotes right there. So I took the y minus k, took the x minus h, which happened to just be an x, and I put it over a divided by b. That means the square root of 36 divided by the square root of 1. Vertices and foci. So let's go to vertices. Now we can see what the formula would be. It would be h comma k plus minus a for the vertices. Let me write vertices here. So in our problem, h is 0. The k is a negative 5. Plus and minus a, we know a is 6. So that's how the test will probably have them written out. If you look at the graph, what it's going to do is it's actually going to add those. So we'll have a positive 1 and a negative 11. So when I look here, 0, positive 1, 0, negative 11. Those are in red. I knew that because of this right here. So that's what the calculator showed us. 0, positive 1, and 0, negative 11. Okay, and then the foci. Opened up foci. It says it's h. I'm going to redo this. I'm looking at this. I'm going to make it simpler. It's h plus or minus c. H comma k plus or minus c. I'm sorry. So in our problem, it would be 0, comma, negative 5 plus and minus. Did I ever say what c was yet? Let's find out what c is. Square root of 37. And that's how it'd be written on the test. If you want to know what that is as a decimal, it's 0 comma negative 11 point whatever, and 0 comma 1.083. Let me go in the same order. 1.083 and 0 comma negative 11 point. I think it's going to be 083. Let's check it. 083, yeah. I'm going to update that for the C's to make that easier on both of these problems. So that'll show up later for you. All right, number 12. Write a standard form of the equation. So we're writing an equation of a hyperbola. So we're writing an equation for a hyperbola. If you look at the formula chart, that's where you have something squared divided by a squared. minus another parenthesis squared over b squared equals 1. That's what the formula chart would say. For which the transverse axis. Okay, vocabulary. Transverse is just like major, and it's just like vertices. So major, if it was an ellipse, oops, I started to write major ellipse. Any of these three words all have the same formula. What are all those three equal to? 2a, 2b, or 2c? 2a. So it says 2a is vertical. That means that a is dealing with y. The fact that it's vertical means that a is connected with the y. So that would be x there. And it's 12 units long. So if 2a equals 12, what does 1a equal? A equals 6. And so what does a squared equal? 36. And then when you come over to the asymptotes, it tells you something that the asymptotes is plus or minus 3. Now, what does that actually mean? Well, if you look on the formula chart, we're on hyperbola. The side of the formula that has the y squared in the positive parenthesis or positive fraction. It tells us that the asymptotes are a divided by b. So that means a divided by b equals 3. A divided by b equals, so this is, I'm taking this right here. A divided by b equals 3. Plus or minus 3, granted, but 3 is what I'm paying attention to right now. We know what a is. A is 6. So if I did my algebra here, I would, I don't think it'll be 12. So we'd have 6 equals 3b. And then you would divide by 3. And so b equals, I wrote 12. B would equal 2. So what does b squared equal? 4. And as far as transformations go, shifts, the asymptotes would tell you. If you had a shift, the asymptote, according to the formula, would tell you. So the fact that it just has a y and an x by itself means that x and y are by themselves there. That would be the equation. You wouldn't need the parentheses. You could simplify and just say y squared over 36 minus x squared over 4 equals 1. That would be the answer. Go for it. Number 11. Here we go. Another one of those flight of a ball. So this is a projectile motion. Remember, there's 6 pieces of information. You don't have to have all 6. But we will write down, you do need to have these first 4. This is the order I have it written on my calculator. And I'll put a red G because it's G, they won't tell you. You just have to go off of if it's feet or meters. The optional pieces are the X and the Y. But these 4 they must give us. So Aaron kicks the soccer ball with an initial velocity of 55. And that's feet. So 55 feet per second. Since it's feet, that means gravity is going to be 32. We cool with that? Angle's 38. Does it say anything about a height? It doesn't. So what would you assume if you're kicking a soccer ball on a height? Kick it off the ground. Let's assume it's off the ground. I'll put ground here. That's an assumption. So we're putting 0. Those are the 4 pieces we have to have. After 1.2 seconds, how far has the ball traveled horizontally? These are the optional pieces. And the answer is, we don't know. Well, you can actually solve this problem really quickly using algebra, but I'm going to use my calculator. And I'm going to go to projectile motion. And we'll plug in the same values. We just had 55 feet per second. Angle, I forgot the angle, 38. We're going to say it was hit from 0 height. Gravity is at 32. Remember, those are the 2 numbers. You don't have to memorize that. You just go off of what the problem is. We want to know how far has the ball traveled at 1.2 seconds? Up here at the time, if you type in 1.2, it gives you the point. If you click it, that's how far it's traveled. 52 feet. When I round, I'm going to say 52 feet. Okay, now you might be thinking, you said it was going to be easy with algebra. Why would it be easy with algebra? Well, this particular problem, where's my formula chart? It doesn't ask anything about vertical at all, and it gives you the amount of time. So you don't have any unknowns other than x. You could just use one equation to solve this problem. You could say that the x would equal that time. Let me just write out the formula once. So we could say the x distance, that 52 feet, is going to equal 1.2 times 55 times the cosine of 38 degrees. And you can see why I didn't even put a height in there, is because you don't even need it algebraically to solve this. It doesn't matter what the height is, it travels the same distance in 1.2 seconds. It doesn't matter if you kicked it off a building or if you kicked it off the ground. Horizontally, after 1.2 seconds, it's moved the same amount of distance left and right. And so let me just type this in here. 1.2 times 55 times the cosine of 29 and, oh, not 29, 38. There we go. 52, same number. Same number that we got right there. More exact number though. So that's how you could do that, by hand and by calculator. Number 12, write a standard form of the equation of a parabola. Okay, so we're writing an equation of a parabola. So that's where you have a parenthesis squared equals 4p times another parenthesis. Again, that's on the formula chart. We've gone there a number of times. That's there. It says a directrix is x equals -2, and a focus at 4, 2. Okay, let's go to the formula chart now. And for a parabola, we're looking for the directrix that's x equals -2. That means I'm on my left side, because that's what has a directrix that's x equals. So I'm using everything on the left side, which means I'll have an equation y minus k, x minus h. The directrix, they said, is equal to the formula h minus p. The focus, if you didn't catch that, the focus, I'll just show you so you can see it, is h plus p, comma k. H plus p, comma k. So we can establish right off the bat what k is. K is going to be +2. And so when I plug this in, it's going to look like a lie. It's going to look like y minus 2, because it replaces the k and not the negative, just the k. So it looks like y minus 2. If we did a little algebra 1 or algebra 2, did a little algebra, let's just be a little bit more vague. We could say that -2, since -2 is x, you could say -2 equals h minus p. And we could say that +4 represents h plus p. I'm going to use elimination technique here that we learned in algebra. If you had two equations that where they're aligned, like terms are aligned like this, and you can eliminate a variable, which in this case we can eliminate p's, you can combine these equations. So -2 plus 4 is similar to saying 4 minus 2, which is 2. I'll have 2 h's and no p's. So when I divide by 2, I find out that h is 1. So we'll plug that in. Again, it's going to look like a lie. So it'll look like x minus 1. And to solve for p, I just plug this into one of these equations. I like dealing with positives, so I'm going to take that equation. 4 equals 1 plus p. And I plug in the h. And so we just subtract 1. And find out that p equals 3. So if p equals 3, then 4p would equal 4 times 3. What is 4 times 3? 12. That would go there. All right, so here we are, number 13. We've seen a problem like this before. How would you solve number 13 to identify the graph of the equation given there?
You just graph it.
Just graph it. Let's figure out what that is. I'm going to get a blank graph. I'm seeing the whole equation right there. I know it cuts off half the test, but it is the whole equation. 8y squared minus 7xy plus 3x squared. By the way, you haven't seen an xy yet. What this does is it rotates the shape. So whatever the shape is, it gets rotated. It also eliminates a circle from being the answer here. It's not going to be a circle if you have an xy. So it's rotated. What is that shape? An ellipse. So we have an ellipse here that's rotated. For fun, and I mean fun, I need to show you this. This is just good breakup. So rest your brain just for a split second here. I'm going to go to conics in general form. Click this. And I'm going to graph this. So I have 8x squareds, which are y squareds. So that means my c is 8. I have 3x squareds, so a is 3. B is xy, so I have -7 of those. I don't have any x or y's by themselves. So 0 here and 0 there. And f is, well, it's 15, but on my formula, I put f on the left side. So I actually need to put this in as -15. Okay, so what's happened here is you can see this graph is rotated. On my graph, I went through, and as you can see here, I've done all kinds of work. I show you what would be the y-axis and x-axis without the rotation. Okay, so this graph has been rotated, but if you wanted to look at it, what would it be without the rotation? This would be the y-axis, this would be the x-axis. You can get all the points from here when you click them. They tell you what everything is. If I zoom in, you'll see the focus here and here. They're hard to see. I just know where to look. And I spent so much time on this. I added in a lot of stuff that's calculus related. These are Directrices. That's what it's plural instead of Directrix. Directrices on ellipse. These are called the Lattice Rectum, but there's 2 of them. So Lattice, I think I forget the exact term for plural, but that's what that is there. It's the width at the focus. It's the width of the shape of the focus. That's what that part is. So anyways, I think that's kind of neat just to see how it's been rotated, that it still is an ellipse. There still is 2 points that are closest to the center than any others, which we call the minor axis or co-vertices. The minor axis is the distance from there to there. You'd still have 2 vertices, which are the farthest points away from the center. Those make up the endpoints of the major axis. So all that's still on there. Number 14, write the parametric equations, x equals 4t squared and y equals 2t minus 5 in rectangular form. Now this one, if you remember, this is where we do this 3 steps, which you could graph these, by the way, and just check graphs, see which ones match. You could use that technique. But I'm going to do step 1 is you solve for the shared variable. What is my shared variable in this problem? T. So we'd solve for what is shared. I think on my test, I know Alex has showed you one way where you always start with the x equation. On my test, I don't necessarily make it that way because in higher level math, you don't have to solve where y is the dependent out front. So you can solve either variable. On this time, I'm going to use this equation. I think it's just going to be easier. Or if not, we could share the other one. But I'm going to use this one here. So the shared variable is t. I'm going to take the y equation just because I wrote this test and I know how I wrote the answer. So I'm choosing the y equation and I plug it in here. What's the first thing to do here to solve for t? plus 5. So I know when I taught you this the first time in lesson 7.5, I saw the x equation and then plug into the y. That's because your homework suite wants it that way. But on the test, it's not necessarily going to appear that way. Okay, what happens next? Divide by 2. And so we have t equals y plus 5 divided by 2. Now, after you solve for what is shared, step 2, you substitute. And so we would have x equals 4, and instead of the t squared, we're going to replace t with y plus 5 divided by 2. Now, I don't remember if I left the answer in this form or if I simplified it, but step 3 is to simplify. And so if we were to simplify this, you'd have x equals 4 times, I'm going to write that parenthesis twice. It'll just make it easier for me anyways. Y plus 5 over 2 times y plus 5 over 2. I'll distribute the 4 through first. Now I'll do the parentheses. I'll multiply parenthesis times parenthesis. So that's going to equal, the denominators will be easy. It'll just be 4. 2 times 2 is 4. Let's see, for the top, we need a FOIL here. I'm going to FOIL this in the numerator. Y times y is y squared. Y times 5 is 5y. 5 times y is 5y. 5 times 5 is 25. You can see these 4 multiplying, 4 dividing will simplify out of there. And so our final solution would be y squared plus 10y plus 25. That would be one form. And or I notice that's a perfect square. It could also be written as y plus 5 quantity squared. It could come either way. I just know that's a perfect square. If you do your x method, factors of 25 that add to 10 are 5 and 5. So it'll be written one of those two ways. Could you have graphed this? Yes. So now that I do that, let me show you the graph. Parametric equations. It was x equals 4t squared. Y equals 2t minus 5. So they gave us this looking graph. You type in the answer choices, no matter how I give them to you. Whether I say it's x equals y plus 5 quantity squared. Let me make that a normal y, lowercase. There we go. You can see these graphs, do they match? They overlap? Yep. I could write the equation the other form, y squared plus 10y plus 25. Even if the answer choice was written this way on the test, those overlap. Or if I just left it in this form, all of them will show you the same answer. All of them overlap one another. So that's a way of graphing, just to get your solution as well using calculator. Ooh, this one here. Identify the conic that has an eccentricity of 5/4. You could play around for a while, but there is a rule to this, and it will look like this. Let me draw the shapes out. I'm going to start with the circle. Then I'm going to have an ellipse. I showed you this in lesson 7.2. Then I'm going to go parabola. Where's parabola? There it is. Parabola. Can I do it the other way? I'd like it to do it the other way if possible. Yeah, there we go. Parabola. And then also hyperbola. All right, here's the rules for eccentricity. If the eccentricity equals 0, it's a circle. If it's between 0 and 1 is an ellipse. If it equals 1, it's a parabola. If it's greater than 1, it's a hyperbola. 5 divided by 4. 5 is bigger than 4. It means it's greater than 1. It's a hyperbola. If worse came to worse, you could open up each one of these graphs. A parabola, an ellipse, a hyperbola. You can graph each one of these and a circle here. You could open up those links and look at the eccentricities. They're listed, and you'll see the hyperbola is the only one with the eccentricity greater than 1. To kind of give you an idea by guessing. You might not be able to get 5/4. That's how you can kind of guess your way through that. Number 16, write the standard form of an equation of a circle. Ooh, here we go. We haven't done this yet. Of the circle. Well, a circle's formula is right here. It's really simple. There's only one formula. X minus h quantity squared plus y minus k quantity squared equals the radius squared. The center is 4, 6. That's h, k. And that's tangent to the x-axis. Ooh, do y'all remember what this word means? I showed pre-AP this earlier in the year. I know. Tangent to the x-axis. What tangent means, let me first tell you what it doesn't mean. What secant means is that a secant line is a line that goes through the shape more than one time. So like on this graph, the x-axis is a secant line. Secant means it goes through more than once. A tangent line means it just touches it barely one time. It just touches it barely, just barely like that one time. Okay, the center of this problem tells us is at 4, 6. 4, 6. That means the x-axis is 4. The y-axis is 6. This can get tricky. I want you to think about it. If it's tangent to the x-axis, that means the radius. What's the radius length?
4.
And that's why it's so tricky. Everyone always says 4 because that's what it's connected to. But it's not. My drawing is technically bad. This radius, how high, it's an up and down value. How high is that over here?
Is it 3?
No, it's 6. It's 6 units. From the center down, it's 6 units. So the radius is 6. So the equation would be x minus 4 squared. And I'll correct my picture in a second. Y minus 6 quantity squared equals 6 squared, or 36. We might put 36. So the radius equals 6. Okay, I'm going to correct my picture. If the radius is 6, then the y-axis would need to be like a secant line here, like that. There you go, because that's only 4 units away. So a circle would extend beyond it. So there's a better drawing of the picture. So the y-axis would be a secant line. That's a good note to have. The y-axis is a secant line. Whoops. That means it crosses through twice. The x-axis is a tangent line. It means it only touches it one time. And not more than once, just one little spot. All right, let's take a look at 17 here. It says a railroad tunnel is shaped like a semi-ellipse. That means half of ellipse. The height of the tunnel at the center is 24 feet. I'm going to go to my drawing and say the height of this is 24 feet. They don't give us a point here, so I'm going to actually label this as 0, 0. It'll make it easier. So I can just say the height here is 24 feet. It'll be 0, 24. Or the old way is by saying 24 feet right there. And the vertical clearance must be 10 feet. That's the y, must be 10 feet at a point 20 feet from the center. So if we go over 20 feet on the x-axis, If we go over 20 feet, the y height needs to be 10. Well, let me go off of this to make it to scale. Let me say that that right there is 10 feet. So let me slide this one over a little bit. What we're saying is when the y-axis is 10 feet, not 24, but 10, the x-axis needs to be a 20 value. So that right there, we're going to say is 10 feet. And the 24, I'm going to now just move that off so I'm not confused. So now I have a point 10, no, I'm doing it backwards, 20 comma 10. Now you might remember me saying this earlier, that when you have a shape, any random point on the shape is a x and a y. That ultimately any graph is a collection of a whole bunch of x's with a whole bunch of y that depend upon the x. That's why we call x independent, y dependent. So for all these independent x's, they have these dependent y's that paired up with them. And when we see the collection of points together, we see this graph. This point, I'm going to call 0, 0 my h comma k. That's going to be either a vertex or a covertex. So it says write the equation for the ellipse. Here's what we know right now. That we have a parenthesis squared over a squared plus a parenthesis squared b squared equals 1. That's what I know right off the bat. We also know that no matter if we put an x and a y, I'm just going to put x for this problem. I'm going to put x in the front, y in the back. It'll have a 0 and a 0, which basically means I'm going to have x squared and y squared. Now, ultimately, we don't really know which one's A, which one's B. We don't know, is this wider, is this? We can look at the picture, but we really don't know if it's drawn to scale. They didn't tell us if it is. But I do know the y value, it goes up and down 24. So for this particular problem, I'm going to say b equals 24. Because remember, 2b would be the minor axis. And so I'm just going to use, since I have this set up with a b under y, I'm going to say b is 24. So this will be 24 squared for my equation. Which means I'm missing a. How could I find a? By plugging in this x and y. We could solve, and I'm going to use nsolve here, by plugging in the x and y value of 10. I'm going to say x comma y equals 20 comma 10. And so what I will plug into the calculator, I'll nsolve, is that 20 squared over a squared plus 10 squared over 24 squared is going to equal 1. We could simplify, but we don't have to. I'm going to use Desmos nsolve here, my very first graph. Nsolve, and we're going to type in this equation. The steps, there's 3 of them. You first type in the equation as given, but you have to use the variable x. So I'm actually going to replace this with an x here. I'm going to put this in as an x into Desmos like that. That's how I'm going to actually type it in. So it was 20 squared divided by x squared plus 10 squared, which could be 100 if you want to put it that way, over 24 squared equals 1. So the first thing you do is you graph the equation as it is, then you copy the left side and you paste it y equals the left side of the equation, and then you copy and paste the right side, which is just a 1. The intersection is going to be our answer. We're only going to use positive answers, not the negative here. And so this answer is approximately 22. So I'm going to say it's approximately 22. So now coming back, that a value is approximately 22 that we just found. A is approximately 22. And so the equation, now that I know that, I was wrong saying A and B. This B is actually going to end up being an A. I have it there, so I'll leave it. But because this number is larger, you would actually look for the equation where, let's find out what 24 squared even is. 24 squared, 576. So it'd be y squared over 576. I'm putting it into formula chart form over x squared, or plus x squared over 22 squared. Let's find out what that number is. 484 equals 1. That would be our equation there. I'm not sure, but I'm wondering if it would be reasonable or not to go to ellipse and just kind of guess. If we know the center is supposed to be 0, 0, I'll put 0, 0 for h and k. And we know the vertical piece is 24. These are the pieces we knew. So in this case, for my formula, it's a 24, like that. If we knew it's supposed to go through the point, it needed a vertical clearance 20 feet away. If we know it's supposed to go through that point, let me make this black so it stands out a little bit more. What you might be able to do is just play with your A and just go one by one to see what number goes through it. How about that? See how that just worked? Never had this tool before to play around with it that way, but that would be a way of using a calculator to try to solve the problem for you until it goes through that point. So 22 would be the answer there. All right, let's take a look at 18 now. It says a radio telescope has a parabolic surface. If it is 30 feet deep and 200 feet wide, and so 30 feet deep, 200 feet wide, how far is the focus from the vertex? Round to the nearest tenth of a foot. Now, the focus is the letter P again. So the formula from the formula chart says you have a parenthesis squared equals 4p times another parenthesis. The focus is a reflection point. It's going to be somewhere in the center of the shape. We don't know where, but it's going to be located somewhere in there. Which way is this focus moving? Up and down, like the Y. That means it's going to go next to the Y. I'm going to go ahead and set the vertex to be 0, 0, which means we could reduce our equation to x squared equals 4py. Now we just have to plot one point. So anywhere on this parabola, you could choose any point on this parabola because that's just a collection of a whole bunch of x's and y's. Let's use this one right here. I like positive numbers. Those are positive. Let's just say 100 squared equals 4p times 30. And let's solve that. Does anybody know what 100 squared is? Be 10,000. You'd have 4 zeros instead of 2. And then over here, it would be 120. And so to get our answer here for how far is the focus from the vertex, it'll be whatever 10,000 divided by 120 is. 10,000 divided by 120. In case you don't know, let's just do it. 100 squared divided by 4 times 30. It's that number. I type it like I had it written out right here, you get the same thing, 83.3333. So P says round to the nearest tenth. So the distance would be 83.3. And we are in feet. So my focus would actually need to be for the proper drawing. If that's 30, that might be 60. So somewhere in there. That's where the focus should actually be. All right. Last two problems here. Adriana hits a softball with an initial velocity. Okay, so we can already tell it's a projectile motion question. If you remember, there are 4 required values: the initial velocity, the angle, the initial height. We will determine gravity based off of the units we're using. And there are 2 optional values that they may give you, an x and a y. I guess I should include t in there. It might include a t. We got that before. I'll put t on there. So let me correct myself. These over here are the required values. So it says we hit this velocity at 79 feet per second. Okay, so as soon as I see that this is a feet per second, what is gravity going to be? 32 or 9.8? 32. Angle is 40. It says how far will the ball travel horizontally? That's what we're trying to find. If Adriana Bat was 33 inches from the ground, so this is inches. So to convert from inches to feet, you divide it by 12. There's 12 inches in 1 foot. So that would cancel out the inches units. And now we'd be in feet. Round your answer to the nearest foot. How far will the ball travel horizontally? So we're going to test it until the ball hits the ground later on. Till it hits the ground. I meant to write hits ground. I don't know what I was about to write there. Hit grounds. Let's go 0 until I take the parenthesis away. I think you can slip the rest of the word away. Does it break it apart? No. Until hits ground. Put a parenthesis that way. There we go. So these are my values. So let's go to that calculator for projectile motion. For me, it's number 23 here. And we'll type in these values. So we have 79 feet per second, 40-degree angle. It was 33 inches, so 33 divided by 12 is 2.75 feet. We want to know optional distance. It is 32 feet per second. The optional distance is we don't know x, but we do know the y vertical is going to be 0. We want to know how far does it go when it hits the ground. You can do one of two things. You can either scroll to where it says projectile at when it hits the ground down here, or you could look at, if you put in the y value as 0, you could look at projectile when it reaches y height. These two values here, 3.2, 195, are going to be the same as these values, 3.2, 195. You can see it solves the same thing. So that's the answer. Here it says how, again, far will the ball travel? It'll travel 195 feet when we round to the nearest foot, approximately 195 feet. And now we'll do one more time on number 20 here. Distress flare is shot 80 degrees up from a ship's bridge 102 feet above the water with an initial velocity of 156 feet per second. So again, what's the required information we need? We need to determine the initial velocity, the angle, the initial height. Gravity will come off the units that we're using. The optional it may give us a t value, an x value, or a y value. All right, so going through there, they gave us the required angle of 80 degrees. The bridge is 102 feet above the water. What is that? Is that my initial velocity or my initial height? Height, that'd be 102. We're in feet. This is feet. We're in gravity is 32 feet per second squared. An initial velocity of 156 feet per second. So we want to know what's the maximum height and how long is the flare above sea level. So for part A, we want to know the maximum. Part B, when it hits the ground or at sea level, which is like the ground, but water. All right, so let's go through and type these values in. 156, 80 degrees, initial height is 102. So there it is. Again, it was gravity. End result, we don't know this part. We want to know the maximum height. So if you go to, in the end result, that is one of the two at the very bottom. It always finds the maximum height and when it hits the ground or sea level in this case. So here's part A. Here's part B. Part A specifically says, what is the maximum height of the flight? So A is the maximum height. Maximum height, is that a X, a Y, or a T?
Oh, what?
It's a Y. So if you go to the maximum height, it's the Y. It's 470. It says round to the nearest foot. So 471 feet. And then part B, how long is the flare above sea level to the nearest 1/10 of a second? That's a time. So the time it hits the ground is, or how this is solved, time for it to hit the ground or sea level is 10.2 seconds. So rounding to the nearest 1/10 is 10.2. So 10.2 seconds, it's above. For 10.2 seconds, this thing is above sea level. Let me add some time to this so you can see it. Where's the graph? Graphing tools. It needs to graph a little bit more time. As you can see, obviously it hits the ground there. Let's go, or it hits the water. So let's go 11 seconds. And I'll show you here if I do the object. Here goes the object up. At 10.2, it's going to be just above sea level. Oops. See, 10.2, it's just above, but at 10.3, it's going to be underneath the water. So the answer is 10.2. Wow, that's it. That's your whole test. You feel ready?